Hi, hello everyone. This is Luca, and this is the continuation of our two-part series about WebGL and then post-processing with WebGL. And in this part, we're going to continue from where we left off, which is this effect which we created. And by the end of this video, we're going to try to create this kind of effect. And the good part of this kind of effect, and really the goal of this video is for you to be able to create all kinds of effects with the knowledge that you're going to get here. And for example, if this effect uses multiple textures, this is really important, and it uses kind of time and a bit of randomness as well, just to create this kind of effect. And you can see scale lines going here. Here it's bended a bit, we're going to get to it. Anyway, the important part is what is the important part? Yeah, the important part is you're probably going to be able to create this kind of effects by the end of this video. And if you wanna, if you haven't followed or you just joined, or maybe you just want to download the code and then start again. So we were working on post-processing and we had part one. We're done with that, and now we're in part two. So if you don't want to continue, or you just joined, you can download basically this. The link will be in the description below. Go to WebGL, set up part two, and you can download the start. So this will be our starting point, or you can download the end as well and then just follow the video and play the video code. The end is just something that we're going to have by the end of this tutorial. Also for this kind of video, you're going to need these textures. So we're going to be using all three of them, and you can download them from the link, which will be also in the description of the video. And with that, we can get started. So we have this, and now, let's just add our textures, which I already downloaded. So, like I mentioned, we're going to be using the noise texture, the scan lines as well, and this vignette kind of effect. First, we're going to do vignette effect. So let's see. Just edit here, and then we're ready. We can already probably start. So let's see what we're going to be doing. Uh, just a second. Okay. Let's see. So, what do we want to do? Let's take a look at this thing here. So, if you don't know what I'm going to be doing now, I'm going to explain it in a second. But basically, what I'm using here is Spectre.js. It's a plugin for either Chrome, or Firefox. I'm not sure about the other browsers, but you can probably find it by looking for Spectre.js and see if your browser is supported, and you can download it. And then if you have a WebGL rendering, you can just record the whole frame, and then you basically see all your WebGL calls and what we were doing. For example, we were drawing a cat here, and we have this cat, right, texture, and then we had a second call for draw elements, which was for this fox, etc., etc. And then by the end, when we were doing this effect, we were using post processing. We were using WebGL frame buffer with color attachment 0. You can see here frame buffer. We were rendering basically to texture, and then by the end, we were actually rendering to our screen, which is canvas frame buffer, right? Because we're rendering it to canvas element in HTML. And then you can see here we were using our screen texture. We were rendering to that frame buffer to this texture, and then we were using it and then creating this kind of effect, grayscale, with our original texture, dot multiplied by some values, which gave us kind of brightness value, if you will, or luminance, and then we just use this luminance for RGB and what is grayscale effect. So what we're going to be doing now, what am I doing? I'm not sure. Let's see. What we're going to do now is just to have multiple textures, combine them, maybe offset them or do some colors. We're going to be using this as well a bit later, and then we're just going to create CRT effect, which I canceled when I paused the video. Anyway, not that important. So let's get started with this. Here in the main TS. So we're probably going to need this buffer texture location, WebGL texture. So because we're working with multiple textures, so we're going to need to know addresses essentially of them, and how to reference them from the CPU to the GPU to tell WebGL, okay, now use texture 0, texture 1, which will be our screen texture, maybe randomness, noise texture, maybe will this kind of vignette effect. So we're going to need all of this, and then we're going to need vignette. So let's just call it vignette texture, which is here, this one. So first we're going to do this kind of edges on the end of the screen. So what we're trying to do is have this, where are you, CRT television, yeah, that's good. So we're going to try to emulate this kind of old TVs, right? Maybe, maybe by adding this kind of edge effect, so you can use different textures as well later on. So let's start it. I need this, I need this, and I need this. So vignette, we're doing vignette texture, WebGL texture, and then we also need location. Right? Okay. So here we're going to need the address, frame buffer texture location, GL get uniform, and I'm going to use, sorry, we need first to pass shader used. If you remember, it was post-process program, and I'm going to call it texture 0. So I'm probably going to have to rename it, and then here is WebGL uniform location, because it returns, if you remember, null as well. So we just need to cast it, and then where is it? There is a setup. Oh, okay. Let's do it here. Function setup CRT textures, maybe something like that. We're just going to need to call it here, and then let's load our textures. Let's shamelessly copy paste from here to here, and this will be our, I always do this, vignette. Okay, that's vignette. So here we're not passing here this, we're passing it, I believe it was called vignette texture. So basically this ID which you added here, right, this one, we're getting this image element by ID, and then right, paste it right here, and then we just have to cast it to HTML image element. That should be fine. If you remember, we had this create texture function, basically, which creates WebGL texture, binds it, passes data to it. Here it passes image or canvas as HTML element, and then that just set of some parameters, and then returns the texture. So where were we? We were somewhere here. Okay, that's fine. So this is important part which we need to do. GL bot bind texture, GL texture 2D, not 2D actually, and here we need frame buffer texture. So because we're going to be using multiple textures, we really need to set this up so that our frame buffer knows what to use. Maybe probably better here. And then here, after we use the program, we're going to have the frame buffer texture, but we also need to pass some additional data. So here I will be using this, and we're going to say, what are we going to say? Frame buffer texture location 0. Yes, that should be fine. GL active texture, GL I'm going to explain in a second. So let's just type screen texture. Let's shamelessly copy and paste it. And let's just say vignette. So you can guess what we're going to do here. Vignette texture. We're going to be placing here and here also vignette texture. Here must be location, right? Let's do here effect. So let's rename this actually to texture one, and then just like here screen texture. So basically, when you're working with WebGL, OpenGL, or whatever, it will create these sample locations, right? This might be 0, this might be 1 in that order, right? Because in programming everything starts from 0. And basically, what we want to do is just say, okay, this texture locations goes to 0. Let's activate the texture 0. So we're saying now use this and this texture, and then we just say which texture to buy. Anyway, this is a bit hard to explain. I really hate this API. But essentially what we're doing here is just setting up our frame buffer texture with the location to the unit 0, and here it must be unit 1. So we're setting 1. So this is something that you're probably going to repeat a lot of times in WebGL. The API is just like that. Okay, and here now we're going to use those textures. Let's do here. It's not. Let's just call it vector for screen. Let's just pick color. Okay, we don't need dot. We're not dot multiplying anymore, and we don't need this. So we're just going to return original texture, color, and let's deal with texture unit 1 in a second. Of course, that this had to happen because I probably have a bug somewhere. Let's see. Actually, let me do this. Let's see. Oh, texture 7, blah blah blah. Cannot convert. That's interesting. That's interesting. Did you refresh everything? One bug is probably here. It's this stupid thing. No, but this should be fine as well. Oh. Oh. Oh, wow. Brilliant. Okay, alright. This is wrong, but okay. Let's see. What am I doing here? You haven't really programmed if you never run into bugs. That's quite common. And then here, what did I say? I said, oh boy. Here this is not important. What's important is it's already going to know which texture to use. So because of the frame buffer here, I actually wanted to do this. Heck, we have to return because right we here bound to 1, and now we have to return it back to GL texture. I guessed it 0. Okay, interesting. Let's try to do this instead. If I mixed up the texture units, I have somehow I mixed up the texture units. Well, for me, that's because I wanted to use actually texture 1 here. So let's see. That's life. frame buffer texture location texture. No. Maybe it's just the fact that I'm not using both textures and shader is doing something wrong here. Okay, let's go like this, and then let's have for vignette color texture, texture 1, texture chords. All right, and then let's just multiply them together. See what happens. Okay, perfect. So now we're using our original texture, which is this one, and we're using our vignette, and this gives us when we multiply, because our vignette is right here it's white, here it's black. If you multiply, the color black is represented by zeros, color white by 1. If you multiply basically original color by 1, you're going to get original color, right? Because it's multiplied by 1, and here we multiply by 0, so it gets darker and darker, and here it's completely 0. Here might be 0.7, maybe something like that. Here it's 0, so therefore it's black. Okay, and let's just see our texture units. Are the texture units correct? Because I'm not sure. Yes, this should be actually screen texture unit 0. So that's a bug. Alright, found the bug. You might have noticed it, but when we bounded the vignette texture location, I forgot to say use texture 1 instead of texture 0, right? Because our vignette texture is texture 1, so I think that should solve it. Let's try it. Let's just see our texture units. Are they correct now? Okay. Yep. Texture unit uniform 0. So our texture 0. Size 1, that's okay. And then here is vignette texture. Okay, that part is finished. So now the second part is we're going to try to create this kind of a bend effect here. All right, to bend a bit, so to really get that CRT kind of effect. So for this, maybe I'll just type it first. Let's see. Yeah, let's type it first and then I'll explain. So we need this. So we're going to create different coordinates. So we're going to take the original ones, which is UV, and then we're going to give some kind of broadband vector. I'm going to get to that. So what do we want to do here? Just bear with me. 0. Going to explain in a second. So we're going to need absolute here. We have y, right? And vector 2.0. And then I'm going to need to undo this, and that's easy to do. And then let's do this. We're going to have the original ones, and vector city UV, which is just going to be this UV, and maybe some small vector. Well, let's actually do 0.5, and then instead of original ones, we're going to use these ones. And here, here, this is what happens. Okay, so let's explain it. I'm just going to use smaller band vector for now, maybe 0.2. Okay, so basically we have our original image where texture coordinates grow from 0 to 1, and we're trying to do something like this. Let's use this graphing calculator, and let's just say 1. All right, and one is not that useful, but what we're really trying to do is come up with texture coordinates that are going to be, let's zoom here, that's going to be bended a bit. And how did I do that? So basically we need something that goes squared, and you can see here, this is really nice. So basically if we have our, oh wow, this is probably good. Let's try with Krita to draw a bit. Just see. Oh, come on now. Yeah, recall file, whatever. Let's draw. So basically, we have our screen coordinates, right? Oh boy, terrible drawing. Anyway, and for these screen coordinates, like if you imagine like here, like this old kind of TVs, what we're trying to do is like bend it here a bit, right? And bend it here a bit so that our texture will also, right, if we had the original one here, it might be bended a bit. It might end up something like this. Anyway, yeah, so that's, we're just trying to bend our texture a bit, right? If we have original one, and then we're probably going to have a bit bended at the corners, right? Something like this. Sorry for the terrible drawing, but let's get to it. And how do we do that? You can see it here, it's bended a bit, but you can just graph it, right? If you know that our texture coordinates go from 0 to 1, we can just have something squared, right? The square function gives us this kind of bend. So this is linear, right? So you need something squared, and then you just need some factor which is going to really bend it a bit, maybe something like 1.2. No, we actually need small factor, right? You can see it right here. So we had our 0 to 1, and then just by using a bit of well just basic polynomial squared function like high school math, you can figure out how to bend the screen coordinates, right? So here we only care about basically 0 to 1 here. These are our screen coordinates, 0 to 1, and then you can see how it's bended here, and then this translates to this kind of effect where it's a bit bended at the edge. And the reason why we did this, right, is because let's explain it. Here, move from 0 to 1 to minus 0.5 to 0 to 5 space, right? We moved from one space to other, and then just move from 2 minus 1 to 1 space, right? Because we need to bend both in both directions. So where are you? Here, right? You can see it also works for negative as well. All right, and then just as we did that, we just need to reverse, right? We need to return to 1 to 0 space, and we do that here, right? Because we just do operations in reverse. So here we will say move back to minus 0.5 to 0.5 space, and then we have to move back. All right, move back to 1 to 0 space. All right, and this is essentially how you do it. And this function is just like I mentioned, we have to actually use absolute value. It won't work with negative values. I mean it will. It will if you remove absolute. It's just going to be super weird, probably. Actually, it's not that bad. Oh, maybe it works. Let's return it back anyway. But basically, power of 2, right? That's just in WebGL you kind of scare, okay, power of 2 here, 2, and then we just have some bend factor, which is same as here. It's just some small value which will bend this thing, and that's it. So okay, let's go further. What are we going to do next? We bended this here a bit. Let's do noise. Noise will be awesome. Okay, so shamelessly copy paste here, then just go here and say noise. Okay, then go and then just say noise. Copy paste, being lazy, noise here, just call noise. We're going to be using texture 02. Just looking if it's alright. It is, and then we can paste third texture, same as here. Noise must be 2. This must be noise. And here as well, noise texture. Okay, let's just format code. Here, let's go here. Let's see if I love using texture 0, texture 0, texture 1, texture 2. It's just easy to think about, but this can be named differently. All right, let's just check once more. Did I bind it? Ah, okay. It must be texture to here. That's all right. And then texture 2, texture coordinates here, and then let's do this actually. Times equals. Let me just think for a second. How do I want this to do this? Yeah, okay. And let's just add noise here. And for that, we're going to do something a bit different. We're going to say mix. So basically we're going to mix, not multiply anymore, our color with noise color, and let's just take 0.5 for now. Let's see if that actually worked. It actually did. So what did we do here? We just passed our noise texture. Let's check it here. Right? We had our screen texture, our vignette texture, and finally our noise texture. And why did we pass noise texture? Because we're going to have a bit of a noise, right? You know, these old screens had a bit of a noise to them. And here we actually used one texture, we used second texture, and we kind of merged them together, half. Maybe I'll just show it quickly. So this might be easier to understand. So if I say 1, if I say 0.5, I did something wrong here. What's wrong here? Aha, yeah, can be 0, 1. That's an integer, so you must use the decimal point. So it's full noise texture. If I use 0.0, let's put this. If I use some small value like 0.1, it's a bit noisy. You don't see it probably, so maybe 0.3. So yeah, there is a bit of noise, but more of our original image. So it's just kind of linear. It interpolates between the two textures, right? You can play with it, so to figure it out. But anyway, we're going to do this, and now, what are we going to do now? Yeah, let's just do this. Let's pass some float, random. It must be uniform. for our noise texture, we're going to use vector 2 UV x plus. All right, we're going to randomly move through that texture so that we can animate this noise a bit. I'm going to also explain it in a second, but so what do we need? Okay, we need here, please listen to me, random location. So it will be WebGL uniform location. We call it setup CRT textures. Maybe we can rename it later, but let's use this here. Random location in GL, get uniform location, post-process program, and random. We call it random as WebGL uniform location. Maybe I should zoom in because this is unreadable. Okay, what are we doing here? We define random here, and we just need to somehow reference it, right? So that we can send it from the CPU to the GPU. Okay, and then just here somewhere after we bind the post-process program, after we say use program, or you can do it anywhere, you know, between the draw elements and use program. So I'll just do it here. And what do we pass now? So we must be careful now. We're passing float. So uniform one float. So we're passing one float. If you remember, it's floating shader. And so I'm so tired. I'm forgetting the arguments here. Okay, so random location, and we're just going to paste met random. That's okay. That is okay generally. Yeah, that should be okay. And you can see now it's a bit deterring, but it looks a bit weird. You might not notice it, but it doesn't look correct, and that's because it's the texture is claimed to edge. Actually, let's do this, and then it will be easy to explain. Let's just not paste my random for now. You can leave it. I'm just going to try to explain. You can see here, right? Maybe I can do noise. Yes, you can see it now. So basically, our texture is clamped to edge. So when it's out of this screen coordinates, sorry, the texture coordinates that goes 0 to 1, the default behavior is just to use the edge of the pixel and then just, well, basically use it indefinitely. So what we need to do is just change a texture function a bit. So instead of doing this, this should be easy. Let's just say, where are you? Create texture, noise texture. All right, let's just have second parameter here. Let's go to create texture and use, let's just say clamp to edge equals true. And we have these filters here, clamp to edge. So basically texture wrapping, once it gets to 0, it will use the last pixel. You're probably going to understand now, it's a bit weird to explain. All right, if I do the second value and else, by default we clamp to edge, and let's just say GL repeat. All right, you can see now it repeats the texture, right? So you can use also mirror. Let's see now. If I use GL, maybe this is even looks better. Mirror repeat. You can see it now. It looks a bit more naturally. So this is mirror repeat, and if you clamp to edge, right? It does this here. So it basically clamps the pixel. So this is basically U coordinates or ST, or and this is V coordinates. So you can use a mix, right? GL. I'm going to use mirror bit. Let's see here. All right. Anyway, Google it, play with it, and hopefully figure it out. Well, you probably already figured it out. Anyway, let's turn this. Let's actually turn made random here. Where were you? Here. So it's going to be you see now it has a bit of noisiness. Maybe I can even improve it a bit. Let's just set this and -1 so that it goes from -1 to 1. Anyway, it's not that important. And here we're just going to use 0.3. Okay, that's quite high value. Still high. This is a bit okay, but you really want just a bit of this effect. So it's so you might want it to be barely visible. That's fine as well. I'm not sure how it end up in video, but anyway, you get the idea. And finally, our last texture that we need to place to finish our shader. Let's do what was it? Scan lines. Scan line texture. Scan line. Let's just create time. Okay, so we probably need time. Okay. Let's copy pasting. I think I called it scanline. Texture 3, already know the drill. So we're going to use time here. I'm going to get to it in a second. Okay. And we actually need a time here. So every frame, let's just say increase our time plus equals 0.01 maybe, I'm not sure. Okay, we're also going to send our time here. I'm going to explain it in a second as well. Let's just paste everything here. Scan my texture location. You already know it. Okay. See, it's just adding textures and then playing with the values. We're going to need time. Load time. Okay, we're not going to use time for now. I'm just putting it so that we basically almost finished here. Scanline color. Shamelessly copy paste here. Okay, but this is not going to be random, so maybe better to paste here shamelessly and then just say texture 2. Texture coordinates. Actually, let's use CRT texture coordinates. And this must be texture 3. And then at the end we have to mix it as well. And let's just go with really lots of colors. And then we need to fix the bug. Image or canvas is null. Okay, that's easy one. So I messed up the name. It's called scan lines texture. And I probably said scan line. Yes, I did. Perfect. All right. We're almost done here. So let's just tone it down a bit. All right, just to see what's going on. So basically we have our scan lines, but if you remember when I showed previously the effect, the scan lines are supposed to move, and that's why we use time, right? And I'm incrementing time by small amount each frame. So for each frame of animation, time becomes slightly bigger, and now we can just use it here, time, and then we can just say, okay, here actually use x, don't touch x, that's fine, and then just y plus time. And what it's going to do is it's going to loop our texture really fast. Obviously that's not something that I want to do, but it's easy to fix. We can just say, where is my time? Where is my time? Increase it a bit less maybe. Okay, let's see it here. You can see it scrolling. Still really fast though. Let's just do here. Let's add a bit of randomness of time. You actually don't want to do this. You kind of need the delta time between previous and current frame. But anyway, that's not part of this video, and I think it might be fine now. You can see it scrolling a bit. Can we improve it? Can we improve it even further? We can. Let's see. Scan lines are now really. Uh, I want them to be a bit thicker. Okay. Let's just do this. So this will increase them a bit, and I think this should be minus time. Okay, you can probably see them moving, and that's fine. So let's do this. Yeah, bit difficult to see though. But anyway, that's kinda it. The rest of the work is just adjusting things a bit, maybe playing with it. So I can see this kind of, I'm not sure if you see it, but I'm bothered by this kind of mirror-like effect, and that's because of this. So I might just do repeat. I think it will look better. It does a bit, but it's not that much better. But anyway, the rest of it is just playing with values a bit. Maybe you can use a bit different scan lines, a bit thicker or whatever. I don't even need to do x. X can remain as it is. It's only y that's relevant. Yes, exactly. So you can play with the values here. You can mix colors more or less. You can also change the textures. You can use textures that you want to use. The important part is probably learn how to use this tool as well. This will really help you. Here you can see all the textures that we use, but you can just download any texture, replace it, play with the values, maybe do something a bit differently. For example, one nice effect that I didn't do here. I might do it quickly, but it's really a nice effect to use. For example, it's this. You can say here, and let's say this is original color. Let's say it like this. Vec for color. Vec is vec 410. Okay, and then that's okay. And then let's just say here, if I move this, for example, this one is really easy effect to figure out. What I'm doing is just chromatic aberration. I wasn't even planning for this, but okay, it's fine. Then we can do plus vec2 0.01 maybe, and then 0.0, and then just say red. Here we're just going to say green, and then here, oh wow, something is a bit slow on my end, and we can say negative, and then we can say probably blue. I think it should work. You can see this kind of chromatic aberration effect. So basically we get this when we offset colors a bit, right? If you take a color which is RGB and try to offset green a bit, try to offset the blue a bit from red or whatever, you get this kind of chromatic aberration effect. Anyway, that's it. Hopefully you enjoyed it. I will leave all the links that might help you in the comments below. And yeah, that's it. Hopefully you enjoyed the video, and all the best. And yeah, that's it. Hope you had fun with this video, and hope that you really learned it. And goodbye.